All right, good afternoon. This is our video for Thursday, March 19th for pre-cal. We have been solving systems by substitution elimination. So today we are going to take our skills and we are going to solve word problems that involve systems of equations. We're going to be on page 454 to start with. Just a reminder, you should have done your assignment on substitution Tuesday. Wednesday was your assignment on elimination, and then for Thursday you're going to have an assignment on word problems, and then on Friday we will have a quiz over solving systems so far. And for today with our word problems, since we are still solving systems, we are going to be looking for at least two equations for each word problem, and usually, and we'll see a few exceptions as I go through a couple of examples, you should have two variables. And so as usual, the work will be interpreting the words into a system. With your system, you can solve using either substitution or elimination. It will be your choice. And as we work through a couple of these, you'll see that some of them are set up for elimination and some of them will be set up for substitution. So I want us to start on page 454, and I want us to look at example 2. And so with example 2, see if I can get a little bit better view of it. In example 2, it says we have a total of $12,000 invested in two funds, paying 9% and 11% simple interest. The yearly interest is $1,180. How much is invested at each rate? So the first thing that I like to do when I'm working on these problems is kind of assign my variables. So it says that we have two different rates of interest, and so I'm going to let X be the amount of money invested at 9%, and Y will be the amount of money invested at 11%. So I hope you understand kind of the money. They got $12,000. They want to invest it. They don't want to put it all in one basket. So they're dividing it between two different accounts, one earning 9% and one 11%. The higher the interest rate, usually kind of the riskier the prospect. And so you don't want to put everything at high risk, but you also want to make a little bit. So they're trying to figure out how much of the 12,000 was in each account. And to do that, they tell you that, well, let's just start here. There was a total of $12,000, and the total interest for 1 year was $1,180. So remember, we need two equations to go with our two variables. So you'll see several problems kind of similar to this, and hopefully you remember from your Algebra 1 and Algebra 2 days. First of all, we just have a total. We've got $12,000. They split it between two accounts. So X amount of dollars plus Y amount of dollars is equivalent to $12,000. Then the second bit of information has to do with interest. So the X amount of dollars is earning 9% interest. The Y amount is 11% interest for a total of $1,180 in interest. So hopefully you understand how interest works, but they take the amount of money in your account and they multiply it by your interest rate and they add that to your account, and that's your interest. So X amount of dollars at 9% interest, that would be how much interest we would earn on our first account. Our second account would The interest would be found by taking 11% or 0.11 times the amount of money in our second account, and those two amounts of interest added together should equal the total interest of 1,180. So we have our total equation, X amount of dollars plus Y amount of dollars equals 12,000. And then we have what I would call our interest equation. The amount of interest from X dollars plus the amount of interest from Y dollars equals the total amount of interest. So this is our system. Again, you could solve it by elimination or substitution. This problem is really set up for elimination. I'm not going to work through it completely because you can see that in the book. I will tell you the first thing that I would do is multiply the bottom equation by 100 to get 9x plus 11y. And here's where you've got to be careful. You've got to remember to multiply the 1,180 and add 2 zeros. And so that equation just feels a lot more comfortable, and you can easily see how you could use elimination or substitution to come up with your answers. You can see in the book that the X amount was $7,000, and the Y amount would be the $5,000. And so these two amounts add up to 12,000, and if you figured the interest on each one, it would add up to the 1,180. Let's look on page 457 at example 6 for our next problem. And for this problem, it says a small business invests $10,000 in equipment to produce a new soft drink. Each bottle of the soft drink costs 65 cents to produce and is sold for $1.20. How many items must be sold before the business breaks even? So break even is explained up above. It says when enough units have been sold that the total revenue equals the total cost, the sales are said to have reached the break even point. So break even is where the money that you are bringing in is equivalent to the amount of money that you have going out. And basically, you're breaking even. Anything that you make above that would be your profit, or something where you're actually making money. So this problem is a little bit different. The question is, how many items must be sold before you can break even? So we'll let X be the number of soft drinks that are sold. To break even, we want the revenue to equal the cost. So again, this one's a little bit different. So I need a revenue equation. So revenue, so that's where R is equal to C. So revenue is the money that you have coming in. And so it says that they are selling each bottle for $1.20. So the money they have coming in, $1.20 per soft drink. The cost that they borrowed $10,000 that they have to pay back, and then it costs $1.65 per bottle to make. So that's paying for the bottle, the ingredients in the soft drink, the employees, the transportation, so all of the cost in producing one bottle. So one bottle brings in $1.20. The cost that they have, it's 65 cents per bottle, and then they have to pay back their initial investment of $10,000. So those are our two equations. Notice that we've got R and C, but over here, break even means that your revenue is equal to your cost. So this problem is set up for substitution. We want our revenue to equal our cost. And then you could quickly solve that. And you can see in the book where it says that they need to make approximately 18,132 bottles to break even. So you can see from the two examples, our first example was set up for elimination, whereas our second example was more of a substitution. So on each word problem, once you have it set up, you can figure out how you want to proceed to solve it. And next, I would like us to turn to page 461, and I want us to look at number 70. So page 461, number 70. So remember, we're looking at our information, trying to kind of come up with two equations, possibly two variables. So on 70, it says we have a choice of two jobs. It says you are offered two jobs selling college textbooks. One company offers an annual salary of $25,000 plus a year-end bonus of 1% of your total sales. The other company offers an annual salary of $20,000 plus a year-end bonus of 2% of your total sales. How much would you have to sell in a year to make the second offer the best offer? So you've got two different jobs. They have an annual salary that's different, and they have the percent that you get bonus-wise based on sales is different. And so the first job, you have a larger annual salary but a smaller bonus. The second one, you have a smaller annual salary but a larger bonus. So if you were a better salesperson, you'd probably want to take the second job. So you're just trying to kind of figure out what would make the second job a better offer. So really you kind of want to figure out, well, what would make them equivalent jobs, and then do you think you could sell more to make job number two a better deal? So this time the unknown is the amount of sales, because your bonus depends on how much you sell. So we have job number one. It's $25,000 whether you sell anything or not. And then in addition to that, you get 1% of everything that you sell. Job number two is only $20,000 guaranteed, but you get 2% of anything that you sell. So again, the idea is, trying to figure out when is job number two a better deal. And so you want to kind of figure out, well, how much would you have to sell for each job to be equal? And then if you were better at selling, then job number two would be better from there. So again, this one is more of a substitution. You're just going to set the two problems or two equations equal to each other. And then you could quickly solve for x. And I'm just going to go ahead and put that down here. And so basically x would be $500,000. So if you sold $500,000 in sales, the two jobs would be equal. So if you could sell more than $500,000, job number two is a better deal. So I want to look at one more real quick on page 462. Just kind of showing you a little bit of variety. You will have problems from both sections. I want to look at page 462, number 76. And so for this problem, it says find the dimensions of the rectangle. On 76, the perimeter is 280 centimeters and the width is 20 centimeters less than the length. So when it says rectangle, dimensions, we're talking about the length and the width. And it tells us the perimeter is 280. And it tells us that the width is 20 centimeters less than the length. Remember, with less than, order is important. So you want 20 less than the length. So remember that perimeter from our study of formulas. Perimeter of a rectangle is 2 lengths plus 2 widths is 280. Our width is 20 less than the length, and then this one would be set up for substitution, and again you could quickly solve it. So you're going to have word problems. Your objective is to figure out what are your two equations, and then sometimes they're going to be two separate equations. Sometimes they're going to be two equations that you want to put equal to each other. I guess they'll still be two separate, but you want to put them equal to each other. So just kind of work through the problems, try every one of them. Let me know your questions if you want to email me what your questions are. I will try and include answers to those questions in our video tomorrow. And then we will have our quiz as well on Friday. So your homework for Thursday, page 461, I want you to do the odd 67 through 71, 75 through 77, 79 and 80. Now notice 76 is here. You can go ahead and finish this problem. We've got it set up for you. On page 470, I want you to try 63, 65, 67, 73, and 74. So these problems will be due Thursday. And again, email me your questions. And so for Friday, what I will do for the video is I will give you the answers to the questions that you send me, kind of like we do in class, where you can ask me questions over the homework. And then after our Zoom session on Friday, so you can send me the questions and I'll put them in the video, but I'll also be available during the Zoom session. And then after the Zoom session, I'll open up your quiz for you to complete for Friday.